Okay, we are on to acceleration now. So acceleration is the rate at which velocity changes. So we talked about that a couple slides ago. A rate is sometimes like based on time, but it's really just sort of a ratio or a fraction. Okay, so the rate at which velocity changes, or how much time the velocity it takes for the velocity to change. So our bodies don't really feel velocity if the velocity is constant, but it would feel acceleration. So like if we're in the vehicle and we're going 50 miles per hour, it almost feels like we're just sitting still, right? But if we slam on the brakes, then our body feels that. It wants to keep moving forward. Or if we speed up, our body feels that. Um, so a car changing speeds or an elevator, we feel those types of accelerations. Or sometimes if it's slowing down, it's referred to as like a deceleration. So it isn't the fall that hurts, it's the sudden stop at the end. And our acceleration detector is in our stomach, right? Okay, so acceleration is a vector quantity with magnitude and direction. And the change in velocity, sorry, give me 1 second, is going to have this like triangle V for change in velocity. Okay? So, for instance, if we have this initial velocity of 8 meters per second and this final velocity of 20 meters per second. So the change of velocity is final minus initial. So final was 20, initial was 8. So our change in velocity is equal to 12 meters per second. Okay? And another way that you can do this with the arrows is you could say, okay, final is going like this, minus initial. So you have to subtract that initial. Okay? If you're subtracting it, then you change the direction that it was originally going. Well, what's the difference of that? This to this point. So it's that far. Well, that's that arrow right there. That's the change of velocity, which is also known as the acceleration. Okay? So this is showing, well, what if you were originally going 20 and then you slowed down to 8? Well, it's still final minus initial. So you have 8 minus 20, which gives you negative 12 meters per second. So initially you're going, you have final minus the initial, right? Like that. So your change is going to be this negative amount here. Okay, so you're going towards the west. Well, in order for it to slow down like that, the acceleration has to be opposite as the velocity. So that's why the acceleration vector in this case is pointing towards the left, because it's going to have to be opposite of whatever that final velocity vector is facing, which is towards the right. All right. The direction of the acceleration vector is that of the change in velocity. So this is just showing you that you could do your you have your final like this, and your initial is pointing towards sort of like the northwest. Your final is pointing towards like the southwest. So the change in that is going to be pointing straight down. Well, whenever you're going in a circle like this, your acceleration is always going to point towards the center of this circle. Okay, we kind of get into that when we talk about like centripetal acceleration, but that change of velocity is always going to point towards the center like that.
And you can kind of do it the same way that we did before too. So we have final minus initial. So it's got to be like 180 degrees from that. And really, I did that wrong. Sorry. It's got to be 180 degrees from this, right? So it's kind of like this right here. Well, if you do the difference of, it's going to point right towards the center, which I didn't do my arrow very long, but it would end up pointing like right towards the center, just like this one down here. All right, so we have some equations here. So your acceleration is equal to change in velocity. So I would do like this on your PowerPoint. You should have the blank one here. So change of velocity over time. It gives you this example here of, say, 20 meters per second divided by 5 seconds. And acceleration is measured in units of meters per second squared. All right, I have a few more examples, but I'm gonna go ahead and end the video here.